Simplifying radical expressions, part 2. So when you're ordering radicals, if you have 3 times the fourth root of 8, 4 root 2, and 3 times the third root of 5, because they all have different indexes, to compare them, we're just going to type them into our calculator. And the way that you should type this, for the first one, would be 3 times for second function yx 8. Or if you have a Texas Instrument, you would do it the backwards way. So when you type this into your calculator, you should get 5.045. 4 times the root of 2 is 5.66. And 3 times the cube root of 5 is 5.13. So to order them, we would go from greatest to least would 5.66, 5.13, then 5.045. So 4 root 2, 3 times the cube root of 5, and 4 times the fourth root of 8. So this would be in order from greatest to least. The division property of radicals says that when you have a radical, you can split it into the radical of the top and a radical on the bottom, and vice versa. So if we split this into this, the square root of 16 is 4, and the square root of 121 is 11. So this is our simplified radical. For this one, we have the root of 8 over the root of 27, and if we break up the root of 8, it would be the same as 4 times 2, so 2 root 2. And the root of 27 would be 9 times 3, so 3 root 3. So this turns into 2 root 2 over 3 root 3. Another way that you can write this is 2 over 3 root of 2 over 3. So you can put it right back under the radicals again too. So negative 3 times the root of 24 over 18. Keep the negative 3 in front. This is root 24 over root 18. So root 24 can be broken down to 4 times 6, which is 2 root 6. And 18 can be broken down into 9 times 2, so 2 root 2. So we have negative 3 times 2 root 6 over, this should be a 3 root 2. Now we multiply it in. The 3's are going to cancel, so we're left with negative 2 root 6 over root 2. Or negative 2 root 6 over 2. When a radical is defined, that means that the radical works. So one of the rules that we know is that when you have an even index, the radicand, so everything underneath the radical, has to be positive. So we're going to use this to help define what our x values can be. So we're going to pick whether the x values can be greater than 0 or less than 0. So for our first one, we have an even index, so we know that 27x squared has to be greater than or equal to 0. Because of this, we know that x squared has to be positive because x squared times 27 is positive. Our x value can be anything though, because a negative x value will make x squared positive, a positive x value will make x squared positive. So for the final answer, the fourth root of 27x squared is defined when x is an element of the real numbers. So really, no matter what x value you plug into this equation, it will work because you could never make a negative underneath. For our second one, it's a positive index, or an even index, so we need it to be positive, so negative 12x to the power of 3 has to be positive. To make this whole thing positive, though, x to the power of 3 has to be a negative number, because a negative times a negative will make a positive. And that means that our x value will have to be a negative number because an x value to the power of 3 will make it negative. So that means for this one, the fourth root of negative 12 x to the power of 3 is defined when x is less than or equal to 0. And it can also be 0 because a 0 will work under the radical as well. For this one, for our first one, we want to state whether or not it's going to be defined and simplify. So because we have an even index, but our a value is squared, we know that a can be any real number. Now we're going to break up the 45. 45 breaks up to 9 times 5 times a squared. So 9 times 5 times a squared. The root of 9 is 3. Root 5 stays. Now when you take this a squared out, so you need to take the square root of a squared is a. We put it into the radical in the absolute value signs. So we're left with 3 root 5 times the absolute value of a, when a is an element to the real numbers. For the second equation, we know that the index is positive, so our whole radicand needs to be greater than or equal to 0, which means that b has to be a negative number to make it a positive number. So b has to be less than or equal to 0. Now we're going to split it up. So negative 27 is the same as 9 times negative 3. Keep the negative with the one you're keeping under the radical because you can't take a negative out of a square radical. Now, b to the power of 9, because we have an index of 2, we want to find the highest divisible number of 2 that goes into 9. So how many groups of 2 can you make with 9? So the biggest 2 value is 8, because you can use 8 of the 9. So it's the nearest even number. So we have b to the 8 with 1 b left over. So that means that 8 of the b's are going to be able to be square rooted with 1 b left over. So we're left with 9 times negative 3b. We can combine this and this because they're staying under the radical, and then b to the power of 8. So we're left with 3b4. When b8 comes out, it's a b to the power of 4 times the root of negative 3b. Now a way to remember this is if you were to think of b to the power of 9 as a factor tree, you would have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. B, 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 B. If this was your factor tree, this comes out, this comes out, this comes out, this comes out. So that would be b to the 4 with 1 b left over. For this one, we have a fourth index, so we need this to be positive. So that means that z has to be positive. And because this is a prime and this is a prime value, we know that we can't factor or can't simplify anymore. For this one, because our index is 3, you can have a positive or a negative underneath the radical, so it really doesn't matter what you have, so y is an element of all the real numbers. So now we need to break this up into cubes, so 8 times 3. Now we look at how many groups of 3 can go into y to the 5. So there's 3 that fully go in with 2 left over. So it's the root of 8 times the root of y to the power of 3 times 3 times y squared. So we're left with 2y. This turns into a 2. This turns into a y. Root of 3y squared. When y is an element of the real numbers.